Other examples of units that you'll encounter in everyday life are units that describe density and concentration. Right, so density describes compactness or crowding. You might talk about population density, information density for storage on a CD or a DVD. Okay, or we could talk about material density, such as the density of water or things that float or sink. Okay. And then units of concentration typically refer to things that are a mix of substances. Right, so we could talk about air pollution, cigarette pollution in air, medicine dosages in the blood, or even blood alcohol content, which is the concentration of alcohol in the body. So let's look at an example. Again, this is a personal one, but let's look at an example of cigarette smoke, at the concentration of cigarette smoke in the air. All right, so one of the things that I like to do in the summers is go to drive-in movie theaters. So if you've ever been to one, they're kind of neat. There are a number of these in Pennsylvania, and you just drive in and you can park your car and you watch movies just sitting outside, either in your car or in the truck bed or something like that. One of the things I don't like about this is that it's outdoors, so there's no regulation on smoking. Most of the theaters allow people to smoke. And I have asthma, so I always struggle to breathe a little bit if there's cars nearby with cigarette smoking. But on top of that, I do worry about the pollutants and the carcinogens in the cigarettes. So I was at a drive-in theater a few weeks ago, and the smoking was worse at that one than it usually is. So I estimated there were about 5 cigarettes at adjacent cars to me being smoked. And I thought I would actually just go through and actually calculate the concentration of cigarette smoke and see how harmful it is. So I wanted to know if I'm panicking for no reason or if this truly is harmful. All right, so there are actually over 4,000 carcinogens in a cigarette, but one of the ones that's more harmful is the level of PM 2.5. Right? And this is a measure of particulate matter that measures 2.5 microns in width or smaller. Right? So to give you an estimate of how big that is, that's about 30 of those would fit on the width of a human hair. Okay, so these are really small things, and these are harmful because they can get into your lungs and settle more deeply than some of the larger particles. Right, so this is just one of the harmful substances, and there are some guidelines for what levels of PM 2.5 are safe. So I found from the WHO, the World Health Organization, levels of 25 micrograms per meter cubed. Right, anything less than that daily is considered relatively safe. All right, so if you want to look at the your metric chart, right, you can see the microgram units, right, and then this is per cubic meter of air. Right, I also found some different estimates from the Environmental Protection Agency, and they had two. The short-term standard for it's the National Ambient Air Quality Standard, right? And I'll post links to all of this so you can see the information after the fact here. But the short-term standard, they recommend less than 35 milligrams per meter cubed, right? Or long-term daily exposure should be less than 12 micrograms per meter cubed. Okay, now this is micrograms of this PM 2.5 substance per cubic meter of air. All right, so to figure this out, I had to try to figure out how many cigarettes are being smoked, what the level of emissions was for them, and then some sort of an estimate for how much space. All right, so all of these estimates deal more with indoor air, but it's of course different if you're outside because it is dispersing into the atmosphere. It's not as contained. Right, so my calculations here are definitely a very, very much an estimate, but at least it gives me sort of a starting place to see what levels we're talking about here. Okay, so I did some research. One of the things I looked up was just the air pollution level, because this does vary from state to state, county to county, country to country, and there is already some particulate matter in the air depending on where you are. All right, so this drive-in theater that I was at a few weeks ago was the Garden Drive-In, which is in Luzerne County, Pennsylvania, and the average daily air pollution level there is about 10.3 micrograms per meter cubed. Okay, so the daily level there is just under the EPA's daily recommended, and the cigarette smoke, maybe it pushes it over the top. All right, so that was an interesting thing to try to figure out. I had to look up emissions from cigarettes, and there is a variety of data. So I went with one peer-reviewed study on Marlboro cigarettes, and I just picked a sort of a low-level one. There were some other cigarettes without filters that had higher levels, but the one that I picked was 667 micrograms per meter cubed, but that was in a 2.88 meter cubed space. Okay, and they picked that number because that's about the size of some cars. So the study was dealing with cigarette emissions and secondhand smoke in cars and what those levels were. Another estimate, I needed to talk about the airspace, the volume in meters cubed. Right, so I wasn't in a car; I was in this open space. So what I did is I found an online tool where you could use Google Maps and you could trace out your area, and it would tell you the area in square meters. And then I just made an estimate that the cigarette smoke, maybe it sort of lingered in the air for about 2 meters, maybe like 6 feet roughly in height. All right, so I took the estimate of the drive-in and I sort of sketched out like my immediate area around some of the cars, right, or where I saw 5 cigarettes being smoked. And this was 819 meters squared, right? And then I estimated again about 2 meters in height. Okay, because then after that I was just sort of assuming it would be far enough away. Again, that's sort of a wild assumption there, but it's a place to start. All right, so I multiplied this by 2 meters in height and got an estimate of 1,638 cubic meters of air. Okay, so what I wanted to do was to let's find now the concentration of those PM 2.5 particles in the air. All right, so I started by multiplying the Marlboro cigarettes, all right, concentration times the space that it was in times 2.88 meters cubed, and all right, and then that equaled 1920.96 micrograms. So the meters cubed canceled out. All right. Then to find the concentration in my drive-in theater space, okay, I divided that by 1638 meters cubed. Right. Now that was for one cigarette, and I estimated there were about 5 going at any given point in time. So I multiplied this by 5. Okay, and then this gave me a level of 5.86 micrograms per cubic meter. Okay, so that, and then combine that with the Luzerne County concentration, which was 10.3. Right, and so that gives a level of about 16 micrograms per meter cubed. Right, so again, I've made quite a few estimates here, and I think somebody with more scientific background than me would perhaps know a bit more about how cigarette smoke is distributed in the air. I suspect that the levels probably weren't that high, and this is assuming that there was no wind. Okay, but I would assume if the wind's blowing, maybe it's a lower level than this. All right, so this may be kind of high, but it did sort of reassure me. So I went back and again to just look at those levels. Right, if it's at 16 micrograms per meter cubed. Right, so that is more than the daily level, but I don't typically go to the drive-ins every day. Right, so it's still under this EPA's estimate for a good short-term level of exposure, and it is under the WHO level as well. All right, so I think it's, it's probably still harmful, but it's a lot safer than I was imagining that it would be. Now, one thing that's interesting from this is that actually the air pollution had more of an effect than the cigarette smoke. Right, so neither's great, but it seems like air pollution is actually worse. And I found, I'll post this link as well, but I found an article that compares air pollution to cigarettes, right? And they've come up with the number, that one cigarette is equivalent to an air pollution of 22 micrograms per meter cubed for 1 day. All right, so in other words, anytime you smoke a cigarette, that's equivalent to being exposed to this level of air pollution for a day, which is higher than the daily recommended. And their article makes this equivalency by looking at the deaths per cigarettes per year and the deaths per air pollution per year, and then compares those two numbers accordingly. So that's where they're coming up with that. And it's an interesting study. If you read through the article, you will need to make all of those unit conversions, but you have enough tools to do that. So you can actually read through and see if these numbers make sense and if you buy this. All right, so it is a leap to compare deaths per year and say that that's equivalent, but it's an interesting comparison. And then if you actually look at world pollution levels, the pollution in the U.S. on average, all right, is about 9 micrograms per day, per meters cubed per day. All right, which would be the equivalent of smoking about 4/10 of a cigarette per day. Okay, and then compare that to China on average, which is equivalent to about 2.4 cigarettes per day. And actually, numbers in Beijing on average are even worse. Beijing air pollution is equivalent, according to this one article, to about 4 cigarettes per day. Right? And then Shenyang, the worst ever recorded air pollution, was equivalent to smoking about 63 cigarettes per day. Now again, those numbers are taking into account all of the health impacts of smoking cigarettes, not just the PM 2.5 levels. Okay, so like I said, I'll post the links to all of the articles and tools that I mentioned, and you can read through that on your own and see what you think about those numbers.